Welcome to Geometry 6.1 to 6.4 review. All right, let's get at it. Tell whether the information in the figure allows you to conclude that point P lies on the perpendicular bisector, or neither. Okay, explain your reasoning. All right, so first of all, point P is here, and we have the segment being bisected, but there is no perpendicular. So not enough information, no perpendicular symbol. Okay, the next one, we have perpendiculars, but we don't know if PD is the same as PF. There's no marks there, so no congruent segments. So not enough information. And then here we have 290 degrees. We do have the marks. So yes, point P is on the angle bisector. All right, so now we go to number 4. Find the indicated measure. AB, we want this right here, this length. All right, so we have these two marks. So this is an angle bisector. So we set these two equal to each other and we solve. So negative x plus 25 equals 3 times 2x minus 8. Distribute, so negative x plus 25 equals 6x minus 24. So we're going to add x to the right, and that would be 7x minus 24, and 25 equals that. We're going to add 24 here, that's 49. Divide by 7, x is 7. Okay, now we've got to put 7 into this position to get AB. So that's negative 7 plus 25, which would be 18. Okay. This next one, we want the angle UTW. So we want this whole angle here. So the first thing we have to do is understand this is an angle bisector. These are the same. We have our 90-degree angles. So we set these equal to each other. 2x plus 3 equals 5x minus 24. So we're going to subtract 2x to the right. That's 3x minus 24 equals 3. Add 24, that's 27. Divide by 3, x is 9. So now we plug 9 in for one of the x's. So 2 times 9 plus 3. So 18 plus 3 is 21. So that's 21 and that's 21. So the whole angle is 42 degrees. All right, write an equation of the perpendicular bisector with the endpoints here. All right, so first of all, what do you need? You need the slope. So slope is 2 minus a negative 2 and negative 3 minus 5. That's going to be 4 over negative 8 or negative 1/2. So the perpendicular slope is positive 2. All right, next thing we need midpoint. Okay, so the midpoint goes over here to the left. The midpoint is negative 3 plus 5 over 2 and 2 plus a negative 2 over 2. So what is that? Negative 3 plus 5 is 2. 2 over 2 is 1. And 2 plus negative 2 is 0. 0 over anything is 0. So that's our midpoint. The original slope we found to be negative 1/2. Perpendicular slope we found to be 2. So we plug it into the linear equation. So y equals 2x plus b. And now we substitute our midpoint. 0 is y. X is 1. So 0 equals 2 plus b. Subtract the 2. So y equals 2x minus 2, because negative 2 is b. All right, so that's our final answer. All right, so now let's see if we can find the indicated measure. Okay, so AP, A to P is what we're looking for. All right, so we have a perpendicular and it's a bisector. All of these are perpendicular bisectors, which means point P is a circumcenter and is equidistant to all the corners of the triangle. Okay, so if PB is 15, that means AP is 15. All right, now MP, let's use a different color here. MP is this little perpendicular there. All right, so P is made from angle bisectors, so that means it's equidistant to the side. So if PN is 11, that means MP is 11. Oops, 11. Find the coordinates of the circumcenter of the triangle. So let's plot these. -6, 12. So we go over to -6, 1, 2, 3, 4, 5, 6. Okay, -6 and +12. Right there, that's A. And B is at 14, 12. So that's a horizontal line, that's good. And C is at -6, 2. All right, so this is great because we have a 90-degree angle. And we want, so we know this is perpendicular here. And we want the circumcenter, so we need perpendicular bisectors. So this is C. So AC is vertical, so let's find the midpoint from A to C. So we're going from 2 to 12. That's a difference of 10. So if we just count up 5, 1, 2, 3, 4, 5, that's the midpoint. And since it's vertical line, our perpendicular bisector is going to be horizontal. Now AB, we're going from -4 all the way to 14. So that's 18 units long. So half of 18 is 9. So count 1, 2, 3, 4, 5, 6, 7, 8, 9. That's our midpoint. Or you can use the midpoint formula just to make sure you find it. And since AB is horizontal, the perpendicular bisector would be vertical. Okay, so my hypotenuse is not drawn correctly. That would be the perpendicular bisector circumcenter right here at this point. So that is at 3, 7. So 3, 7 is the circumcenter. All right, G is the incenter, and L is the LG, is 6x minus 14, and G is -3x plus 22. So incenter means you have angle bisectors, and they're equidistant to all the sides. So that means these two things are equal to each other. 6x minus 14 equals -3x plus 22. Add 3x. You get 9x minus 14 equals 22. Add 14 to 22, you get 36. Divide by 9, you get 4. All right, so x is 4. Now it wants to know mg. So mg, we don't have anything for, so we got to figure out one of these other ones. So we're going to substitute x in for the LG expression. So 24 minus 14 is 10. So each of these are 10, which now we can say mg is 10, and ng is the same thing, 10. Okay, now we got a circumcenter. Circumcenter is a point that is equidistant to all the corners of the triangle. All right, so GL, let's just change these different colors. GL is the same as GE. Oh, I'm sorry. So GE and GK. So GK and GL are the same, but it's not the same as GE. So this looks like either a mistake or trying to trick you. All right, so that means we have to set 4x minus 2 equal to 2x plus 8. So they were trying to trick you. So minus 2x is 2x minus 2 equals 8. Add 2, 2x equals 10. Divide by 2, and x is 5. All right, let's plug it back in to one of these. 4 times 5 minus 2. 20 minus 2 is 18. So each of these is 18 units long. All right, so GJ is 18. And GE, we don't know, but x's are the same in all of the expressions in the picture. So we have to plug 5 in for the GE section. So 3 times 5 plus 2 is 15 plus 2 is 17. Okay, you're installing a fountain in this triangular pond using the concepts from this chapter. How you make sure the foundation is the same distance from each side. So that means you're using incenters, an incenter, which is angle bisectors. Angle bisectors meet at a point called the incenter. And where they meet, that'll be equidistant to the sides. Okay? All right. That's all it was wanting you to say. All right. So let's go on. Point P is the centroid. Centroids cut the medians into thirds. All right. So one of these is longer than the other. So BP and PL. So let's make this BP and then PL. So PL is half the length of BP. So BL, the whole length, is 12. So we divide it by 3, and PL is going to be 4, and BP is twice that. So that's 4. That means that must be 8. Okay? Okay, now CP. Okay, let's highlight this. CP is 16. All right, that means LP is half of that. That's 8. And CL is all of it together, 24. All right, the next one, number 3. AL, the whole thing here is 27. So we divide by 3, and PL is going to be 9. And that means AP is 18, twice that. All right, again, PL, this short leg here, is 102. So we double it to get BP, which it would be 204. And together, that makes 306. All right, find the coordinates of the centroid of the triangle. All right, so centroid uses medians. All right, -6, 8. -6 and 8. All right, that's A. B is at -3, 1. And C is at 0, 3. Okay, so there's that line. And we connect all these as straight as we can possibly make them. All right, so we need to find at least 2 midpoints. So let's just go ahead and find the midpoint from A to B. Midpoint of AB, it'd be -6 plus -3 over 2, and 8 plus 1 over 2. So -6 plus -3 is -9, over 2 is -4.5. 8 plus 1 is 9, that's 4.5. All right, so AB is at -4.5, 4.5, which is right, right there. Now let's do BC. So the midpoint of BC is going to be -3 plus 0, and 1 plus 3. So that's -3/2, and 4 over 2 is 2. So -1.5 is -3/2, and up to 2 right there. All right, so let's draw these. And when we do that, we see our coordinate is right there at -3, 4. Okay, that's your centroid. Let's do the next one. So tell whether the orthocenter of the triangle of the given vertices is inside, on, outside the triangle. Then find the coordinates. Okay, so let's graph it. -1, 5 is Q, and 4, 3 is R, and -1, -2 is T. Okay. So now we gotta connect all these. So that slope is up 1 over 1. So I know TR's slope is 1. Oh, there's a vertical line right there. And there's no perpendicular lines, I can tell. So that makes it a little harder. All right, so we need perpendicular lines drawn from a corner perpendicular to the opposite side. So let's just start with the TR that I have here. So this slope is 1, so the perpendicular slope is going to be -1. So we start at Q. I'm going to do this in yellow. We start at Q, and we go down 1 and over 1, down 1, over 1, down 1, over 1, down 1, over 1. So if we connect all of those, there's the perpendicular line from Q to TR. That's the altitude. All right, so now we need to do, let's do one more. Let's do, since the easy one is a vertical line, so we'll do a vertical line from R to QT. The vertical line, the perpendicular line would be horizontal. All right, and so there we see our point at 1, 3. So the answer should be 1, 3 for the orthocenter. Okay, now, when AB equals 16, all right, what is QS? QS must be 32. All right, now we probably need to change all these because I think they're changing things. So let's find out. When SR, the whole thing here is 68. What is CA? CA is half of that, which is 32. Okay. And SR is 46. Okay, so they're changing the values each time. So let's erase that. Start each problem separately. So now we have SR. If SR is 46, then what is BR? Well, B is the midpoint, remember, so that means this is 23. So 23. All right, we'll erase all that and do the next problem. So now it says CB is 5. All right, so what is QR? Oops. QR must be 10. All right, erase that. And the next problem. SR is 3x minus 1, and CA is 5x plus 4. All right, so let's say this out loud. CA is 1/2 of SR. The midsegment is always half of the side of the triangle. So CA is 5x plus 4, and SR is 3x minus 1. Now don't forget to distribute the 1/2. Or I'll just do that because that's what most of you are going to do. 5x plus 4 equals 3/2 x minus 1/2. All right, so I'm going to subtract 3/2 x from 5x plus 4. On the right side, we have a negative 1/2. Don't drop that minus sign. And we have a plus 4 here. Now, what is 5 minus 3/2? So 5 minus 3/2. Common denominator. So that's 10 minus 3 would be 7/2 x. Subtract 4. 7/2 x equals negative 1/2 minus 4. Get a common denominator. Get negative 9/2. So 7/2 x equals negative 9/2. So we multiply by the reciprocal, 2/7. That makes this x, and that's negative 18 over 14, which is what? Divide by 2, we get negative 9/7. And that's all it said. It said, what is x? That's all we had to do is get that. Negative 9/7. All right, so let's erase all this and do the next problem. So that's negative 9/7. And which line is parallel to CB? So here's C. Let's do it in yellow. Here's CB. So that means QR is parallel. All right. Erase all of that and do the next problem. Which line is parallel to QS? Well, QS is right here, so that would be AB. No trick questions. That's the last question. So hopefully that helps just to see the answers. Good luck tomorrow on the assessment.